So here we're going to talk about factoring trinomials with a coefficient of 1. There's a new method that I just learned probably about a year ago that I actually think works a little bit better than the old method that I did because you can use it for... Now, what it means by a coefficient of 1 is we're talking about like x squared. I always use this example, but 6x plus 9. So our leading coefficient right up here is going to be this number that's right in front of there. So in this case, we just have a 1. Now, anyways, yeah. So I'm just going to dive right into the lesson. So we're talking about factoring by grouping, okay? So what we're talking about is that we are going to group the first two and group the second two. And sorry, I messed this one up. One thing that I always do is I always try, I think this is, will work. Okay. I always bring the sign with me, okay? So then I have to look at this first group and I ask myself, what is the greatest common factor? Well, this has got a PQ and this has got a 5Q. If I look at numbers, there's a 1 here and a 5 there, so the greatest common factor is 5. Or is 1, sorry. If I have a P here, but I don't have a P here. The only thing I really see in common is a Q. When I take out that Q, so that means I'm dividing this by Q and dividing this by Q, I'm left with P plus 5. Hopefully that makes sense. Now, when I look at this, I see a 2 and a 10, so I know I can factor out a 2, but then again, if I divide that by 2 and that divided by 2, I get a P plus 5. Now, the unique thing about this is if we look what's in this parentheses, P plus 5, P plus 5, so that becomes our first set of parentheses. And then our second set of parentheses is whatever's on the outside. In this case, it's a Q plus 2, and we have factored that by grouping. Okay? Same thing with this one. Now, this one I'm going to switch around. It may be hard to see, but if I see a 2xy and a 3y and a 2x and a 3, well, the first thing I notice is there's a 2, and there's a 3, and there's a 3. So I'm going to rewrite this thing. I don't know what's going to happen, but the key is that we want to get whatever is inside the parentheses to be the same. Okay, so that's the key. If I look at this, I see they both have a 2, and they both have an x. If I divide this by 2x, I'm left with y. And if I divide this by 2x, be careful, I'm still left with a 1. Here, I think I can factor out a positive 3. Remember, if I divide this by 3 and this by 3, I'm left with a y plus 1. Now look, we did it. Whatever's on the inside together, and then whatever's on the outside. Okay? This one, I'm not sure. I'm just going to dive right in, see what happens. I see I could pull out a 2a, divide that by 2a, I'm left with a, divide that by 2a, I'm left with that. Okay? I see a 3b, hopefully you guys see that. Divide this by 3b, I'm left with an a, divide that by 3b, I'm left with that, and look, we got it. So this is a minus 2, 2a plus 3b. Okay? So hopefully that makes sense. Same thing with this one. Now, this is where it gets a little bit tricky, and this is why I pulled a sign with me, okay? So if I look at this, I think the greatest they have in common is x squared. Divide this by x squared, left with x. Divide that by x squared, you're left with a 3. Now, I think I can pull out a minus 5. Divide that by minus 5, I'm left with an x. Divide that by negative 5. Remember, negative 15 divided by negative 5 is a positive 3. And x plus 3 is in the inside. X squared minus 5 is on the outside. And we factored by grouping. Okay, so hopefully you got that part, because that's like step 1 for this whole process. Okay? Now, the way that your book says to do this is probably way different than I'm about to teach you, but it's something that I enjoy using, and it's something that I just learned recently, so I'm going to share it with you. So step number 1 is we have to think of the factors of 18. So we talked about this in the first video. So I think 1 times 18 is a factor. I think 2 times 9 is a factor. I think 3 times 6 is a factor. And that's all you can do. Okay? Here, I want my factors to add up to 9. Well, 1 plus 18 is 19, right? 2 plus 9 is 11, but 3 plus 6 is 9. So here's how I write this. X squared plus 3x plus 6x plus 18. So what did I do there? I found my factors that added up to my middle term, and I just wrote them with an x. Okay? Then factor by grouping. Sorry, I forgot to bring the sign. Greatest common factor we have here is an x. You're left with x plus 3. Greatest common factor we have is a 6. You're left with x plus 3. Guess what, guys? X plus 3 is on the inside. X plus 6 is on the outside. And boom, we did it. Okay, so again, factors of 18, figure out what those are. Figure out which ones add up. In this case, with a plus plus, it's always going to be adding. So we're going to have to add them. Okay, we'll get to the harder ones here in a second. Write it as x squared plus 3x. I got the 3 because that's one of the factors here. I got the 6 because that's one of the factors here. They add up to 9 plus 18, factor by grouping. There's my answer. Now this one is where I said it gets a little bit tricky. So again, 24, sorry. I get 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Now, this isn't tricky. I want them to multiply to give me a positive, but subtract to give me a negative. So, which one is it? I'll give you a hint. If it's written like this, negative plus, you're going to need both of these to be negative. So when I do that, I get that. So, it's going to be y squared minus 4y minus 6y plus 24. Oh my goodness. Sorry about that, guys. Let's get back. No clue what happened there. Okay. All right. So then, factor by grouping. Bring your sign, because in this case, it's going to be y. And you're going to have y minus 4. In this case, it's going to be negative 6 on the outside. So this divided by negative 6 leaves me with a y. This divided by negative 6 leaves me with a minus 4, which does give me what I'm looking for here. So this is y minus 4 and y minus 6. So again, I'll give you this little chart. If you have plus plus in your original, you're going to have plus plus. If you have minus plus, you're looking for minus minus. But if you have plus minus, that's going to be plus minus. And if you have minus minus, that's going to be minus plus. So what do I mean by that? So let me make this as like the OG. Oh my gosh. I'm so sorry, guys. Didn't mean to yell. It's Friday. It just doesn't want me to finish. Like, come on, kids. So this is the OG, and this is the new. So if your original problem is minus plus, your factors are going to be negative negative. If they were plus plus like on the first one, they're going to be plus plus. If they're opposite, you're just going to do opposite. Okay? So let's look to see what we have here. So we have an opposite one. Okay? So that means that whatever my factors are, I know it's going to be the opposite. So this is 130, 215, 310, 5, 6. I want this to add up to 1. I think this is probably the closest bet. Now, if you can't recognize this, you want to say that does 6z minus 5z add up to positive 1z? It does. Okay? Factor, bring your negative sign. Z plus 6. Sorry, that's supposed to be a 6. Negative 5. Z plus 6. So I get a z plus 6 and a z minus 5. You're probably like, where's the plus 6 coming from? Well, here, remember, you're dividing each of these by negative 5, and a negative divided by a negative is a positive. So hopefully that makes sense. This one again, OG, negative, negative. We're going to have opposite signs. So in this case, I'm just going to do it real quick. I believe that you're going to do minus 11a plus 2a minus 22. Factor by grouping. I'm sorry, I keep forgetting to bring in that sign, but you have a minus 11. And I think you pull out a 2, sorry, plus 2. Then you have a minus 11. So I think I have a minus 11 times a plus 2. And I'm done. Let's see if I can erase this hot mess, and let's see what they're trying to say. Sorry, guys. Well, that didn't work at all. Oh, yeah. There's only a couple more things. Sorry, guys. Come on, eraser. Erase. You erase. You erase. Back to pen. Okay. So, and this kind of just clears up that chart that I was trying to say earlier. So if both integers must be positive, if B and C are positive, so if this is positive, your factors both be positive. If both are negative, one is positive, the other one is positive, and then it kind of just covers that chart that I said. And then there is something called prime polynomials, okay? So what that means, and I hope you don't run into any of these, if we think of our factors of 14, now remember this is minus plus, right? So they're both going to have to be minus, right? So if I think of my factors of 14, I can do negative 1, negative 14. Well, those add up to negative 15. I could do negative 2 and negative 7. Those add up to negative 9, which is not negative 8. So we call this prime. Same thing with here. This is plus plus. This is kind of nice. The only factors of 2 are 1 and 2, right? That's the only factors of 2. But what is 1 plus 2? That's 3. This is just a 1. So that's going to be what's called prime. Okay. So that's what they cannot be factored using integers.